Okay, foldable day one. So Katrina is going to get paid $5 an hour if she babysits. You're going to complete this table and you're going to find out how much she makes after 3 hours. Determine if it's linear or not, and we'll go over the definition of that. Then you're going to identify the rate of change, which is your M, and your y-intercept, which is your B, in the formula y equals mx plus b. So the y is going to stay, the equals sign is going to stay, your x stays, and your plus sign stays. You're just replacing this m and this b, and then we will finally graph it. So if she gets paid $5 an hour, I hope you understand that if she doesn't work at all, she doesn't get paid anything. After 1 hour, $5. 2 hours, she would then make $10, and 3 hours, $15. So we need to find the rate of change. Now you've already done this before. This is nothing new. We normally wrote the process in the middle before we graphed them. So what happens is you're looking for the change over here. How's this increasing? And this is all increasing by 5, while these are all increasing by 1. So your change in y divided by your change in x is 5 divided by the 1. 5 divided by 1. So yes, it is linear because it's a constant change. These are all increasing by 5, and those are all increasing by 1. So that is 5 divided by 1. It is linear because it has a rate of change is constant of 5. So your rate of change, you would then realize, is your m. That is your 5. Your 0 is your y-intercept. Remember, the most important one is that 0 stage. We've already been over these before. 0 stage, what's across from your 0 is a 0. So if we write it, again, your y and your equal sign stay. Your m is the 5. Your x stays and your plus sign stays, and your b is 0. So the true answer is just a plain old y equals 5x. You don't have to put the plus 0. Now we're going to go ahead and graph it. In order to graph it, you're going to use these dimensions over here. 0, 0 is that ordered pair. 1, 5, 2, 10, and then 3, 15. That's 4 different dots. Okay, so our y-intercept, as identified right here, is where we're starting on the y. So it tells us where it starts right along this y. So it starts at 0. So that means I have one of these, and you're drawing your dot at the 0. So go ahead and put a dot at your 0. Right at the bullseye. Okay, now the next one tells you the rate of change, meaning how it's increasing. So it's increasing 5. That's where you get the over 1 up 5 from. And you put the dot at 1, 5. That's where this is identified, 1, 5. Now for the 2, 10, meaning all I did was go over 1 more and up 5. So it's still the same technique. Up 5, over 1. Same thing. If I continue that process, I have another one, and I need to have it at 5 more up and over 1. So take it and go 5 up and over 1. And that's where that 315 comes from. The 315 is from your table. So really all you have to do is take these 4 and graph them, and it comes up with this. Your y-intercept was here, up 5 over 1, up 5 over 1, up 5 over 1. And that's where these ordered pairs come from. Another thing that you need to recognize right away is that it is increasing. It's going up to the right, so that's why it is a positive slope. This rate of change is positive. It's the angle of that line. So that rate of change is a positive 5, so it goes up to the right. So this one isn't giving us a specific scenario. It's just saying, hey, find the rate of change and your y-intercept, write the equation, and then graph. So it's already filled in the table for us. But what we need to do is find the change in y right here, and that's decreasing by 2, decreasing by 2, and this one is also decreasing by 2. And yes, you need to check all of them. This is increasing by 1, and this set is increasing by 1. So again, the change in y over the change in x is -2 divided by 1 for all of them. So it is linear because the rate of change is constant of -2. Constant of -2 because -2 divided by 1. So your rate of change is a -2. Your y-intercept, again, look across from your 0. When your x is 0, what is your y? And that is a +1. So let's go ahead and fill it in. Your y stays, your equal sign stays. Your m is that -2, your x and plus sign stay, and then your y-intercept, your b, is a 1. You're just taking these two numbers and plugging them in the equation. Okay, now on to the next slide so that we could graph it. Okay, this one we do the same as the last. We identify that rate of change. So we got a change of 2 because 3 minus 1 is 2. 7 minus 3, the difference between these two is a +4. And the difference between these is an 8. 2, 4, 8. So it's not the same as last time. This is increasing by 1. This is increasing by 1. And this is increasing by 1. So if you look at your change in y over change in x, these two become 2 over 1, while this set becomes 4 over 1, and this set is 8 over 1, and those are not equivalent. So that means it is not a linear function. The reason behind that is you need to list your rate of change is not constant because it goes from a 2 over 1 to a 4 over 1 to an 8 over 1. That's from a 2 to a 4 to an 8. So it is not equivalent. And you could actually figure this out by the graph if you had the graph, because what happens is you get something that does not form a line. So when you graph it, you have your y-intercept of 0, 1. It's right at that 0, 1. And then 1, 3. 1, 3 over 1, up 3. And then you have a over 2, up 7. And then you have an over 3, up 15. In which case, you notice it's kind of a curve, so that is not a line, meaning a linear function, line. Okay, let's check for our rate of change. The change between the 0 and the 15 is 15. It's increasing. This is increasing to 15, and this is increasing 15. This over here is increasing by 5. Again by 5, and again by 5. Now, my rate of change, obviously they're all the same. So the change in y over the change in x is 15 over 5, which is 3. When you divide, 15 divided by 5 is 3. So yes, it is linear because your rate of change can be identified is 3. So again, you copy it down here. Rate of change is 3. Your y-intercept, don't forget what's across from your 0. That's where your y-intercept is. Now if I was to build this equation, you have y stays, equal stays. Your m is the 3. Your x stays. And remember, we don't have to write the +0 because it is non-existent in the form of equation. Go on to the next slide and we will graph this one. Okay, so let's identify our rate of change. we have these, if you notice, they are decreasing by a 0.5. These are increasing by a 1. So our rate of change, our change in y divided by our change in x. Our change in y is a negative 0.5 over 1, which is the same as a negative 0.5. So it is linear because it's 0.5 all the way. Yes, the reason rate of change is a constant of negative 0.5. So let's copy it down here, negative 0.5. And of course my y-intercept is located here. X is 0 while y is a positive 3. So my y-intercept is that positive 3. To write the equation, we have our y, have our equal sign still. You put that m in, meaning your rate of change, negative 0.5. You have your x and your plus sign and your y-intercept of 3. We'll go ahead and graph it on the next slide. Okay, so let's practice on the homework. First off, you need to make sure you're very careful with these negatives. These are actually increasing because look, I owe money, owe $3, owe nothing, and then I have $3. So this is a positive increase as I'm going to the right. So let's go ahead and label that. These are increasing by 3. These have a difference of 3. Those have a difference of 3. Again, the same with the top. I owe $10 and then I just owe 8. So that's increasing by 2, increasing by 2 more, increasing by 2 more. So you should recognize right away that your rate of change is 3 over 2. Rate of change, meaning your m. Your m is 3 over 2 in your equation. So since it is constant, that means it is a linear function. Okay, the second one, notice the difference between 5 and 1 is a 4. The difference between a 13 and a 15 is 8. And the difference between a 25 and 13 is 12. Now that's not a problem. It doesn't have to be the same number. You just have to check up here. Now increase by 1, increase by 1, increase by 1. Now because that x did not increase at the same rate, what you need to recognize is your rate of change between these two is 4 over 1. Between these two is 8 over 1. And between these two is 12 over 1. So it is a non-linear, meaning not linear function.